And this is the another refraction question, question 31 from your worksheet, grade 11 physics class. Light travels from water into an unknown material. Angle of incidence is 35.5 and is measured angle of refraction to be 17.4. What is the speed of light in the unknown material? Now right away, I hope you clue in that you can't do this in one equation. You can't solve this in one single step. With angles, we have to work with Snell's law, and that has indices of refraction. So on your formula sheet, Snell's law looks like this. Nowhere on there is the speed of light, but remember the first thing we did for refraction, one of the first things is that index of refraction equates to the speed of light in a perfect vacuum of space, for example, divided by the speed of light in the material. That's where we're going to do our resulting calculations. We're going to calculate what the index of refraction is first, use that, knowing the speed of light in a perfect vacuum is a given, 3 times 10 to the 8, figure out what the speed of light in this material is. So of course you have to be very careful. If you make a mistake with Snell's law, you won't get the correct speed out. So you have to watch that, watch your steps. Now I'm going to reread the question and start writing down what I know, what I don't know. Light travels from water into the unknown material. So water is my incident material. It's my first material. So my index of refraction of my unknown material, being unknown is my question mark, angle of incidence, 35.5 degrees, angle of refraction, about half of that, 17.4 degrees. Now, conceptually, before you even do any calculations, your answer should come out to be, bigger or larger than 1.33. Well, if light slows down in this material, as is indicated by the smaller refracted angle than incident angle, then without even doing any calculations, I know that my index of refraction, my refracted material, my second material, has to be larger than the index of refraction of my incident or water, 1.33. So I'm just going to leave that up there so I can double check that in the end. I know that is one way I can kind of check my answer. Okay, so let's do this out and do some Snell's law. I have 1.33 sine 35.5 equals NR, don't know what that is yet, sine 17.4. So I just work out left and right sides there just to get some numbers, make it a little easier looking. 1.33 times the sine of 35.5, 0.77. That equals sine 17.4, 0.299, and then the next digit's a 0, so put our number there. All right, almost done. Divide both sides by the 0.99, or excuse me, the 0.299, 0.7723 divided by 0.299 equals 2.58. And it's larger than 1.33. Right, bigger than water. So our answer, physics, nature-wise, conceptually, makes sense. Remember, that's not our final question. The final question is, what is the speed of light in this material? So now we're going to use the index of refraction in that material. So speed of light divided by the speed of the light in that material. So 2.58 equals 3 times 10 to the 8 meters per second. 8 over V. Cross multiply, switch things around a little bit. 3.00 times 10 to the 8 meters per second divided by the index of refraction. Remember, speed of light always has to be smaller inside a material than in perfect space. That's a good way to check your answer too. So you didn't make a little mistake. 3 exponent 8 divided by 2.58. 1.16 times 10, and count the zeros there, 8 meters per second. All right, so for those of you still awake, still with me, stuck through it to the end, maybe you fast forward a bit, that's fine, I understand. It's a little dry in the middle. You end up with a speed of light in this material of 1.16 times 10 to the 8 meters per second.